Hello everyone, thank you for signing into my live stream. I'm Mr. Matt and this is Dr. Tot, and welcome to Geometry. Today we're going to be talking about triangle congruence and the specific 4 postulates that correspond to triangle congruency in geometry. Those are the angle, angle, side, angle, the side, 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 and the angle, angle, side postulates. Let me go ahead and share my screen with you. And just a reminder, these are live streams, so there's a little bit of a delay between the iPads, so I'm going to be conscious of that. If you find these videos helpful, then feel free to like my stream and subscribe to my channel. There's a watermark in the lower right-hand corner that makes it like a little shortcut to subscribe, and I appreciate it very much. But otherwise, let's go ahead and get into this today. So the first postulate we're going to look at is the angle-side-angle postulate. And this proves triangle congruency, that proves that 2 triangles are congruent to each other. If they're congruent, that means that they have the same exact side lengths and the same exact angle measures. So they're completely the same. This is in contrast to similar triangles. Triangles that are similar just have proportionate sides. They have equal angle measures but proportionate side lengths. So it's almost like if you take one triangle and stretch it out, but you keep the relationships proportionate between the sides. So it's like shrinking or stretching one triangle, zooming in or out of the same triangle. That's triangle similarity. Triangle congruency, though, means that they are exactly the same. Same size, same side lengths, and same angle measures. So, angle side angle, you can prove this by observing if 2 angles and an included side of a triangle are congruent to 2 angles and an included side of another triangle, then you can conclude that the 2 triangles are congruent. So if 2 angles and an included side, what does that mean? So 2 angles and an included side. So if it's an included side, that means that it lies between the first 2 objects, or between the first 2 angles. So if angle A is congruent with angle D between these 2 triangles, and side length AB is congruent to side length DE, and angle B is congruent to angle E, then this would prove triangle congruency, or this would prove that these 2 triangles are exactly the same triangle because of the angle side angle congruency postulate. Now, it doesn't have to be from the left and working right. It can be any combination, just so long as they're in the right order. So for example, if we started with B, if B is congruent to F and side length BC is congruent to side length FD and angle C is congruent to angle D, it doesn't matter that they're in different positions or they're just rotated. These diagrams may not be drawn to scale, so they might be tricking you with the picture, because sometimes they can tell you that the diagram's not drawn to scale, so they're telling you that it's not a correct visual representation of the real relationships between the angles and side lengths here. So long as you see the congruency patterns, where these signs, the little dashes, mean that they line up, those corresponding angles or those corresponding side lengths are equal to each other. So if you get that pattern that is angle side angle and making sure that the side is the included side, then you know that these triangles are congruent. Let me give you an example of where this would not work. So for example, if we said that angle A is congruent to angle D, and let's say that angle B is congruent to angle E, but let's say that I only say that side length AB is congruent to side length EF. If that's the case, notice that in the second triangle, in triangle DEF, the side length is not an included side length. It's outside of the 2 pairs of angles, so this does not match up. This does not prove triangle congruency because it's not in the order of angle, side, angle. It's angle, angle, side, which is actually another congruency postulate, but they don't match up between the two triangles in question. So this does not prove congruency. If you have any questions, then please let me know. You can drop a comment or question in the live chat function, or you can, if you're watching this recording, you can comment in the section below. Now let's talk about side angle side. So this is just another combination of associated angles and or side lengths between triangles that can prove that the two triangles are congruent. If two side lengths and an included angle of a triangle are congruent to two sides and an included angle of another triangle, then the triangles you can conclude are congruent. So this says, for example, if side length AB is congruent to side length DE, and angle measure B is equal to angle measure E, and side length BC is congruent to side length EF, then you have side angle side congruency, and this proves, or this is demonstrative of the SAS side angle side congruency postulate. If you have any questions, then just let me know, and let me make my camera actually a little bit smaller because I think it's in the way a little bit. The next postulate that we're going to talk about is the angle side. So here, if two angles and a non-included side of a triangle are congruent to two angles and a non-included side of another triangle, then you can conclude that the two triangles are congruent to each other. So for example, if I know that angle A is congruent to angle D, and I know that angle B is congruent to angle E, and I also know that side length BC is congruent to side length EF, then we have angle side correspondence, and we know that these two triangles are congruent to each other. Now again, this can be in any order. So for example, I could say that angle B is congruent to angle E, angle C is congruent to angle F, and side length AC is congruent to side length DF. That would also prove angle side congruency. And lastly, the last combination here, if I told you that angle C is congruent to angle F, and angle A is congruent to angle D, and side length AB is congruent to side length DE, that would also prove angle side congruency. If you have any questions, then please let me know. Otherwise, let's take a look at side. So notice there's no angles in this one. It just merely says if the three sides of a triangle are congruent to three sides of another triangle, then the triangles are congruent. Now, a little forewarning, there is a similarity postulate that is angle. So angle has to do with similarity, not congruency. So don't make that mistake. Side is going to be indicative of that the two triangles are congruent or exactly the same with one another. But if you merely have angle, that means that only proves that they're two zoomed in versions, or they could be two like zoomed in, zoomed out versions of each other. But side, meaning that, for example, AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. That would prove side congruency, and so you know that these two triangles would have to be the exact same triangle, just copies of each other, exact copies of each other. Again, if you have any questions, then please let me know. So those were the 4 postulates, just to review quickly. So we had side, 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 angle, angle, side, side, angle, side, and angle, side, angle. Now we're going to go through other postulates later on that are going to prove similarity, but remember now congruency means exactly the same, and it has to be in this order. It can be any version, it can be rotated any manner around the triangle, or the triangles that themselves can be rotated, but they have to have the consistent pattern listed out by the name of the postulate. Okay, otherwise, let's take a look at some problems. I want you to, oops, excuse me, passed it here. So I'd like you to determine whether the following pairs of triangles are congruent, and if they are, list the triangle congruency postulate that supports your answer. Okay, so I'm going to give you 3 minutes. Please look at these 2 triangles and tell me whether they are or are not congruent. If they are congruent, then list the postulate that supports your answer. I'll keep track of the time down here and I'll update it every minute. Okay, so this problem, we can see that we have congruent sides denoted by the single hash or the single dash mark through the side. So the single marks match up, the single mark on the angles match up, and the double mark on the last sides add up, or match up I should say, or correspond to one another, saying that these side lengths, corresponding side lengths and included angle are congruent. So this does in fact prove congruency due to the side angle side postulate. Let me rewrite that, that got a little messy. So yes, they are congruent due to the side angle sides congruency postulate. If you have any questions, then please let me know. I'm going to give you 2 minutes. Please look at these two triangles. Okay, so with this problem, we can see that corresponding side lengths of single dash marks match up. So side length AB is congruent to side length DE. Similarly, side length BC is congruent to side length EF. And lastly, side length AC is congruent to side length DF. So yes, these two triangles are congruent due to the side-side-side congruency postulate. If you have any questions, then please let me know. Otherwise, let's take a look at these two triangles. I'll give you 2 minutes. I'd like you to tell me whether they are congruent or not. If they are congruent, then please tell me what postulate supports your answer. Okay, so here, notice that we do have corresponding side lengths that are congruent. The 1 dashed side lengths match up, AB is congruent to DE, and the 2 dashed side lengths match up, BC is congruent to EF. However, in the first triangle, the angle is the included angle between the two congruent side lengths. In the second triangle, it's an excluded angle. It's on the outside of the pair. So here in the first triangle, this would be proving triangle congruence if we had side, angle, side. And the second triangle would be proving side, side, angle. Oh, excuse me. I'm thinking of angle, angle, side. I'm so sorry. No, the first one would be side, angle, side. The second one does not match up to side, angle, side, so these are not the same thing. And therefore these do not prove triangle congruence. So the answer here is no. If you have any questions, if you have any questions, then please let me know. Otherwise, I'll give you 2 minutes. Take a look at these two triangles. Okay, so if we look at these two triangles, we see that angle A is congruent to angle E, angle B is congruent to angle F, and side length BC is congruent to side length DF. Even though they don't match up on the sides of the physical positionings, they do match up in their orientation to each other, that it goes angle and then the next angle over and then the exact adjacent side length. So this is angle, angle, side, and if maybe I represent this in a different way, it might seem a little bit more clear. So if I take this guy, and remember that this diagram doesn't have to be drawn to scale. So if I maybe think of it more like this, and if this diagram, I know that these two triangles don't look congruent if I do it that way, but if this is not a scaled diagram and they're just going off of the angle and side relationships, notice that now we have angle, angle, side correspondence. So these two triangles are congruent because of angle, angle, side congruency postulate. If you have any questions, then please let me know. Otherwise, let's take a look at these two triangles. I'll give you 2 minutes. Okay, so looking at these two triangles, notice that angle B is congruent to angle E. Side length BC is congruent to side length EF, and so far those match up as being in the right order. One is following the other because that's angle B is adjacent to the side length BC, which is the same thing that's going on in the second triangle where angle E is adjacent to side length EF. However, this angle of C creates what it doesn't allow for in the first triangle. The side length is the included side length between angle B and C, but in the second triangle we have an alternate. The angle in question, they're telling us that this angle is congruent with the other angle on the opposite side of the first triangle. So this does not prove congruency because they don't match up in the correct order. If you have any questions, then as always, please let me know. Otherwise, let's take a look at these two. 2 minutes. Okay, so looking at these two triangles, notice that they match up with with angle correspondence. Angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. However, angle is not a congruency postulate. It's a similarity postulate. So the answer here is no. They're not congruent. They are similar, but they didn't ask for similarity as to whether the two triangles were similar or not. They asked as to whether they were congruent. And so no, they're not congruent. They are similar. If you have any questions, then please let me know. Otherwise, let's take a look at these two triangles. I'll give you 2 more minutes. Okay, so looking at these two triangles, notice that in the first triangle, the angle is included between the two sides. However, in the second triangle, the corresponding congruent angle is not included. It's exclusive to the two sides. It occurs on the outside. So when I say inclusive, notice there's only one that's in between the two sides here, whereas on this side of the triangle, there are 2 angles that are technically would be inside or between those 2 side lengths. So when they say included, they're talking about the one angle in between the 2 other side lengths. So this does not match up in the sequence that they presented between the corresponding side, or between the corresponding angles. Angle B may be congruent to angle D, but because it's not the included angle in question in the second triangle, it doesn't match up with this congruency postulate. So no, these are not congruent. If you have any questions, then please let me know. Otherwise, 2 more minutes, take a look at these 2 problems, or these 2 triangles rather. Okay, looking at these two triangles, notice that side length AC is congruent to side length DF, angle C is congruent to angle F, and side length BC is congruent to side length EF. And here, the angle is the included angle between the two congruent side lengths. So this is in fact, or these are, I should say, in fact, congruent due to side angle side congruency postulate. And finally, this problem will bring us up to the end of class today. I'm going to give you 2 more minutes. Please look at these last 2 triangles and tell me whether they are congruent or not. If they are congruent, then give me the postulate that supports that answer. Okay, so the last 2 problems here, notice that angle C is congruent to angle F, angle A is congruent to angle D, and side length AB is congruent to side length DE. So it doesn't matter that we're going clockwise or from left to right or right to left. This is the angle side similarity postulate. So these 2 triangles are congruent due to angle side. If you have any questions on anything that we've done today, then please let me know in the comment section below. If you liked if you like these streams or if you find them helpful, then please like the stream and subscribe to my channel. You can hit the little watermark in the lower right-hand corner. It's a little bit of a shortcut to subscribe directly. Otherwise, I hope you have a wonderful day. Again, I'm Mr. Matt, and this is Dr. Todd. Dr. Todd, do you want to say goodbye to everybody? Excuse me, Mr. Todd. Hey, you want a cookie? Did you earn a cookie? I don't know if we earned a cookie. Come on, you gotta say goodbye to everybody. That's your job. Come on. Let's say goodbye. You do a paw, say goodbye. Come on. You can do good boy. There you go. All right, thank you guys very much for watching. I'll talk to you all on Friday.